In this problem, we're going to look at verifying that 1 minus the sine squared of beta times 1 plus the sine squared of beta is equal to 2 cosine squared of beta minus cosine to the fourth of beta. In this one, it's really kind of hard to tell which side is more complex. So just choose the one you feel the most comfortable working with. I think I'm going to start with the left side. So one thing I notice about this particular identity is that we have sines on the left and we have cosines on the right. So my strategy is going to be try to maybe change the sines into cosines. If I had started on the right-hand side, I would have tried to change the cosines into sines. All right, so here's what I'm going to do. I know that 1 minus the sine squared of beta, that's one of my Pythagorean identities. So I know I can change that to the cosine squared of beta. And again, I could use that same strategy, and I could try to change this sine squared of beta into a cosine squared of beta. So again, looking at that Pythagorean identity, I know I can change that into 1 minus the cosine squared of beta. So I have cosine squared of beta times 1 plus, and then in parentheses, I have 1 minus the cosine squared of beta. All right, so now what I've successfully done is changed all the signs on the left-hand side into cosines. Now let's do some simplification and see what we end up with. So inside the parentheses, I can add that 1 plus 1. And so I have cosine squared of beta times 2 minus the cosine squared of beta. And then my next step is I'm going to distribute that cosine squared of beta through those parentheses. So I get 2 cosine squared of beta minus cosine to the fourth of beta. And notice that that verifies the identity. So to recap on this one, first thing I did was change the 1 minus sine squared of beta to cosine squared of beta using the Pythagorean identity. And then I did that a second time within the parentheses. That put everything in terms of cosines instead of sines. And then I just used addition to add the 1 plus the 1 and get 2. And then finally, I distributed the cosine squared of beta through the parentheses.